And today on the bench is a pretty old Yamaha amplifier. It's late 70s, it's the P2201, should be 200 watts per channel. This one's only got the one channel though. And this was released in 1976 and was the first of Yamaha's professional series. It's got a big chunky professional power switch and two professional volume knobs, and it's missing some professional screws from its lid. It's a complete dog. Does look better at the back, mind you. Speaker terminals are in good condition, and it looks like it accepts most input cables. And how's this for a bit of honesty from the audio industry? The rated temperature limited output power is 12.5 watts. It was at least serviced by JD back in 1996, so I assume this happened more recently. Look at the state of that. And it wears its transistors on the outside because that's actually quite dangerous. I mean, seriously, the case is a collector. That could like a positive and negative voltage rail on there. God knows how wide that is. I think I need to proceed with caution. If you've come to watch a man get electrocuted, it's the wrong channel. Oh, apart from that one time. Before I connect it to the test equipment, I make sure the speaker terminals are wired the right way around, so I don't want to blow my scope up. So I want continuity there, and not there. Good. And continuity here. Oh. And that'll be a significant problem that needs the lids come off. Well, this is clearly meant to be because half the screws are missing. But it's quite chunky in there, not much spare room. As far as big amps go, this is quite a simple design. Power supply in the middle and a mono channel either side. And viewed from the other side we can see a problem. Those speaker terminals have got wires on, unlike these. Furthermore, this channel seems to have more components. Yes, a suspicious lack of parts here. They've even unsoldered the input wires. Someone's clearly had a go at fixing it and given up. I wonder what horrors are in store. Oh, I think we've been burgled. And on the positive side, you can't get electrocuted off that bit. Or is that the positive side? I don't know. There's only one screw in here anyway. A rather chewed up one here. I think that's out now. It all looks a bit ropey to me, and there's more transistors missing here. Look at all that crusty stuff at the bottom. I think that was probably glue to hold these down, stop them vibrating. It's gone a bit nasty now. And the absence of 6 power resistors here tells me this thing's had a right bit of a blow up. With so many bits missing, it's a good idea to take the other channel off, use it as a reference, because it apparently works. See how much gives on these cables? Not too much. Solder these. And these. These have been undone before, I can tell. I haven't had to unwrap the wire. These might put up more of a fight. Cut that off to make a bit more room. Now these might be altogether trickier to get off. These are wrapped round, I can tell. There we go, there's one. There's still that thermal fuse that's holding on to this. I'm going to take the board off. I'm going to give this board a good clean before I start working on it. It's just a bit grim really. This transistor's just waiting to get its legs ripped off, so I'm going to just take the screw out of that first. Spare its life. The transistor sockets are just held in with one screw. Bit of a wire bend to get at them. Just surveying what we got, and in the back of this, well, there's some rather horrible soldering, and the solder mask's been damaged on here. Just the extent of the damage, I don't know, so it definitely needs a clean up. Before I throw it in the ultrasonic tank, I need to check for any components which won't like it. Any polystyrene is going to react with the cleaning chemicals I've got. So I think I've got 1, 2, 3. Yeah, it's only 3 on there to take out. Okay, there was 4 of them. And in the tank it goes. Oh, should see a bit deeper than that. Yeah, that basket should come out. It's too shallow. That's more like it. I'm going to give this one a clean as well, because I'm going to give it a bit of a service, even though it does work apparently. Just take this off as well. This one actually has a plate on there, look. Huh. And I'll need to take these transistors out to get the sockets off. Hopefully they all fall out now. Most of them. Just got to pull them out now. And that's easier said than done. They're a bit tight. Pluck these out of the board. And this one's ready to go as well. Although I have noticed, look at this, cracked resistor there. Yeah, that'll need changing I guess. Oh well, off it goes. Let's chuck it in there. Go on, have a bath. The heat sinks are pretty manky too, and these insulators are sort of stuck on there. So once I can free them off in here. With a bit of a brush as well. Well, it definitely needs a clean. It's thick with dust. These bolts just have the look about them of being a bit tight. Yeah, they were. And that reveals a little bit more. Just untether this wire. Just unwrap that a bit. There's another one there wrapped around this cable. That's pretty tight, that is. See if I can unwind it. These ground wires are what's holding it on now. Got this flexible shaft, very good for these situations. I'll take this bottom cover off because it's not really doing anything. I could do the clean. Because a lot of these amps have spent some time in nightclubs, there's always blooming sticky residue. I think it's from the dry ice. You can only get it off with a bit of foam cleaner. So I'm taking these metal shields off. And more dust in here. Comes off easy enough though. I need to take this off so I can actually operate this switch. Held on with a little screw. Let's give it a little dust. Now I can operate it. squirt a bit of contact cleaner in there. Get it all working. And on this side as well. Let's tip it on its side so the cleaning fluid runs down the switch. Just work it a bit. Admittedly, not much skill required for this. No, that's empty. Something different now. What's this? Electrolube. They're all the same, honestly I believe that. Well, I assume I'm going to fix this channel so that can come off. Oh, what a mess. That's quite sticky, so I'm going to try some label remover spray. Hopefully it doesn't do anything I don't want it to. I take all the writing off the panel, because that's never happened before, has it? Will it come off? You have to scrub it a bit, but yeah, this is getting there. I'm all done with cleaning it, and an advantage is it smells better, because to be honest, smell like the bottom of a Hoover bag. There's not many controls on the front, so I'm just going to check that they all work before I bolt this all up. Start with the main switch and check we've got nice 0 ohms across here. That looks good. And this one, perfect. Let's check this fuse as well. Also good. Just checking these pots work nicely. I'm going to put 10 volts across them. I've got the negative rail connected to ground here, so I don't have to mess around with scope probing. Probe the centre pin, which is the wiper. A little bit crunchy at the top. No, that's clearing up. Yeah, that's fine. Probably never dared to turn it up that much. What about this one? That's also a bit cracked at the top, but that's clearing up pretty quick. Look at that. Yeah, that's fine too. This is a particularly difficult screw to get in. Not quite well placed. So the bendy screwdriver comes to the rescue again. Trying to thread this through is a bit awkward. More awkward than the last one. It's got me out of trouble a few times, this old bendy. Now we've got this old metal wire wrapped around here. I wasn't sure what it was trying to achieve by doing this, but I'll make some vague attempt to put it back. Same here. Not really serving much purpose, but it's back on now anyway. Can put the bottom cover back on now. Don't need to get to the underneath anymore. Didn't have that many screws when it came in. Pretty sure there's no problems there, so this cover can go back on without that in it. Now I'm going to have a look at these amplifier boards. They've been cleaned, they've been dried in the oven, ready to work on. You'd have never guessed the board was glossy before it was cleaned, would you? Look at that. Just going to put these polystyrene film caps back in. So I'm not sure that they'll survive the cleaning process. Seems to have an excessively long leg there. Not now. I wouldn't normally change all the caps for the sake of it, but you know what? There's only 5 on here. And it keeps the capacitor police off my back as well. Hopefully these just pull out nicely because they were glued down originally. Looks like the ultrasonic cleaning's weakened that somewhat. Some of these old glues can be a problem in the future because they can absorb moisture and cause all sorts of trouble. Like here, you've got components literally joined together by glue. If it doesn't conduct electricity, that's not a problem, but when it's this old, it's best to get rid of it. This glue here is not going to actually short anything together, but it has gone quite crunchy. Look at that. Just flicks off. You can see how it's changed over the years. Probably new capacitors are a lot smaller, and I don't actually have actual leaded versions of this one, so I'm going to have to put a radial leaded one in. Sort of bend its legs over. Similar problems here, the lead spacing is quite far out. I'll just replace this 10 ohm resistor with a split down the middle. Yeah, this is part of the snubber on the output. Yeah, so it might see a bit of load. It looks to be soldered into a socket. See if it comes out. It all seems to be falling apart. Oh dear. Got the new resistor with the legs hopefully bent to the right position. See if I can get that in that little socket. Now I can put the sockets back into the heatsink. Bit of a fiddle. Little screw in there. One in there. And one in there. This side still had the cover plate on. Hadn't been disappeared like the other side. The thermal cutout switch sits there, and it's annoyingly it's covered up by the circuit board. A bit of a bad design really. We'll manage without it whilst we're testing it on the bench. Let's pop a couple of screws in. This base drive transistor, let's get the cable straight. It went under there. Bit of a fiddle. Let's put a bit of heatsink compound around this hole. I'm going to put a micro insulator on top. I can see where the hole's gone. Where has the hole gone? Oh, there it is. And a little bit more on top. Not much. Then just going to screw this right on top. I put some heatsink compound down here as well to sort of dot it around. It'll all spread out. Got some micro insulators here. Got the original transistors, there's nothing wrong with these. And put a few dabs of heatsink compound on there as well. Okay, I want to power this up on the bench supply first, so if there's anything wrong it doesn't blow up. So I need to know what the connections are. It just happens to be the schematics for this are quite easy to come by. Need to feed it with a positive and negative rail, about 80 volts. And there's another 13 volt AC output here. This is for the transistor bias. And this provides a floating power supply for these lower rail transistors. This supply gives me plus and minus 75 volts. About 0.2 amps that'll do. I make this negative by putting the common like this. Positive rail. Ground rail and the negative rail. Goes on there. Ground on there, terminal E, negative rail there. And this will replace our floating AC supply. It's not sense tap, so that's fine. One on there. Put our speaker outputs there, there's the ground. And that's the positive. Just plug that into the dummy load. Well, I think that's ready to go. Let's turn on this floating supply for the lower rails. Then on with the high voltage. Oh, that's not right. We've got a lot of DC offset there. Oh, look at the power supply. Like no current on the lower rail and too much current on the high rail. Well, this was a working channel apparently, so I must have missed something. The ground on this amp's labelled terminal E. There's also an E terminal by the input. And I have notes on the schematic, the ground here only goes to this terminal E. And there's no internal connection to this one here. So it must rely on the wiring inside the amp to make that connection. So I'll just try a crock clip on there to make a direct link. Ah, that's made no difference at all. Let's try giving it a bit more current. And that's helping a bit. Still not right. What if I reset the supply? See if it works now. There we go. It looks quite nicely balanced now. Obviously needed a bit more sort of oomph than I had given it. So I'll wind this up to the same sort of current, see if it starts up nicely. A bit twitchy. Perfect. Just going to check the bias current with these test pins. It's supposed to be 10 millivolts. That's nearly double. Let's knock it back a bit. Bit much. I'm going to put a test signal in here. Might as well see it run. Well, that's looking okay to me, so that can go back in the amp. Let's not forget this one. First thing we need to put on, because the wires are a bit short, and it's this thermal fuse, and I think this board's got to come out as well. Just add a bit of the obligatory heatsink goop on there. And I'll try my best not to get it on my fingers. Now I can pop the board back on. Bit awkward to get these wires in. Try and hook it down there so I can solder it. And now the black wire. Now the negative supply. I'm going to tin these a lot, get lots of solder on, and make it a lot easier to solder these on. That works so well there, we'll do it again here. That's the easy one done. Now for the left channel. And this is also cleaned up very nicely in the ultrasonic cleaner. Very pleased with that. I'm going to start off by putting these polystyrene film caps back in. So we took them out before we cleaned it. Start with a 560 picofarad cap here. Then a 470 picofarad cap here. 47 picofarads in there. And 100 puff here. Just spotted a very clean looking dry joint there. If I push that, you can see the leg moving. I don't know if the ultrasonic cleaner caused that, but it probably didn't help. Next job is replace these 5 electrolytics. Put our nice new ones in. 470 mic these are. $100 microfarad at the bottom. And finally our 220 microfarad one across here. Tip those off there. Because the main power transistors are missing out of this amplifier, also these 2 drivers here, we have to think something pretty nasty happened around here, so we need to check out all of these components, make sure there's no further damage. I'm going to start with these fusible resistors, these white ones, because they're designed to blow. Start with this one, 22 ohms, this one's okay. A 390 ohm one here, that's okay. 120 ohms, yep. 470 ohms, yep. 220, okay. Another 220, good. And finally 68 ohms, perfect. Now the emitter resistors have been removed off the board, we'll check the bases. That one's okay. So is that one. Good. Okay. Same here. Good. Check out this transistor that lives on the heatsink. There's the base. Collector. That's good. And the emitter. Yeah, that's not short, and that's measuring the 22 ohm resistor. Check transistor 13, sneaking down here. That's okay. And so is that. Any shorts there? Nope. Then transistor 14. That's okay. Okay. Check for shorts. Nope. Transistor 13. Okay. So this is okay, these are okay, these are missing, that one's okay. Just need to check these 2 out, then I'll be happy. There's transistor 8. Okay. No shorts. Good. And here's transistor 9 onto the base. The collector. Good. Emitter. No shorts. Okay. Well, the repair abandoner did at least identify all of the blown parts. Credit for that. So why did they give up? And that was very likely down to the scarcity of these original parts. These transistors are long out of production. Looking for a 2SD381, 2SB536, and a set of reasonably matching 2SC1586s and 2SA909s. You have to be careful when buying replacement transistors, because if they're old and vintage, they're very unlikely to be made recently. In fact, the ones for sale, they call themselves new old stock, most likely fake. And I'll show you what I mean by fake. This is a genuine transistor, rated for about 10 amps. Look at the size of that silicon die there. Nice and chunky. And this is what turned up from China. Had the exact same markings on. Clearly not the same. So after getting my finger stung more times than Pooh Bear, I decided I only fit modern transistors. 2SD381's an NPN transistor. 120 volts collector to emitter, 1500 milliamps collector current, and a gain of at least 40. And the 2SB356 is a pretty similar complementary pair, PNP, only 110 volts collector to emitter on this one, 2 amps collector current, and gain 40 minimum, same again. I think the MGE 15028 and 029 are the perfect match. The collector emitter voltage, 120 volts, that's just the same. We've got a lot more collector current, 8 amps, these are a lot stronger. If we have a look at the DC current gain here, 40 minimum, perfect. And we got our 2SC1586 NPN, 200 volts, 15 amps collector current, and a gain of 30 or more. And the 2SA909, the PNP complementary I suppose, 200 volts, that's the same, 15 amps, and a gain of 30 minimum. It's a similar story for the power transistors, and it's more important because the high powered ones are more likely to be faked and blow up. The collector emitter voltage here, 200 volts, the same as the other ones. Collector current, 16 amps, actually slightly better. And the current gain, somewhere between 15 and 60. I think that's going to be close enough. And here are the brand new parts. These have come from Farnell. I quite like RS components because they give me free shipping. I've never got any bloody stock though. These boxes are rather nice, aren't they? Look at that. The parts inside, that's all. Yes. Oh, must have bought a spare. There we go. These transistors have got to sit in here, fasten this heatsink, but rather than trying to get my screwdriver in, I'm just going to unscrew them. I'm going to put a little bit of heatsink compound on there. Doesn't need much. Just lay the transistors on. Of course I've had to get new screws as well, because they were also burgled. Watch this torque over when I do it up. Very annoying. So transistor 12 is our PNP transistor. Goes there. And transistor 11 is the NPN one. Just put the first screw in loosely so I can line the second one up. Now I can do this one up tightly and nip that first one back up. Got the new emitter resistors, 5 watts, 0.47 ohms each. Let's feed them into these holes. I've actually cleaned these out. I didn't film it, it's very naughty of me. But you didn't miss a lot. Just a few minutes with the solder sucker. Time to mount it on the heatsink now. It's all nice and clean as well. To make sure I've got this the right way round, this transistor's got to go onto there, and these holes are exposed on this side, that's good. So these transistor bases, these will just line up in those holes. Now we don't have the shields put on here, but I don't think it's too much of a problem. There's quite a gap between there and the board. It's not going to short out. So we'll attach this transistor onto the heatsink first. I'm going to put a bit of heatsink compound on. And then pop a nice new mica pad over it. And a bit more heatsink compound on the top. Although I think those are going to be pretty flat. So just get this lined up as close as I can. And somehow guide my screw right through all of the holes, hoping it finds its way. Yes, just torqued up a bit there. There we go. Pop a couple of screws in. Now we're ready to flip this over and put the power transistors in. More heatsink goop around here. Let's pop the mica insulators on. I hope to just drop them on. Don't want to touch that goop too much if I don't have to. Then a bit more goop on top. And here's our new output transistors. A bit more awkward to open. Tape on these. See if we can just drop these in without getting covered in heatsink compound. There's one. And there's three. Now for the PNP ones. Wiggle the legs a little bit. Here we are. I've even had to get more fasteners for this thing. They'd nicked everything. Just got to test it now. Start with the speaker terminals. Put these crock clips on. And our negative supply, ground, and positive supply. And our floating 12 volts on here. Let's not forget to ground the input. We know that's a problem. Fingers crossed. On with the floating supply. Now the main supply. Oh, this looks pretty promising. As does that. Not much DC offset there, if any at all. Let's measure the bias on this. See how it's working with these transistors in. Well, it's a little high. Needs to come down a bit. We're looking for 10 millivolts. The bias current will probably continue to drift upwards whilst it's warming up. It's best to adjust it once it's warmed up and when it's in the actual amplifier where it's got the full power supply connected. Just connecting an input signal to this, just to see if we're getting a proper waveform come out of it. And it does. There's nothing wrong with that. So I reckon that's ready to go back in the amp. Put some heatsink compound on here for the thermal switch. Fold the board back over for the last time. Just connect B plus. Bit awkward. There's a lot of solder on here, so it'll just melt on, I hope. Now the ground. Then B minus. And now the floating supply. Let's get the signal cables on. This is the ground. It's rather hot, that was. And there's a signal. Okay. Let's tin the speaker terminals again. Just with all fresh solder on there. And also preheat them. Same with this one. I should be able to solder this on now. Now to deal with this manky cable, there's nothing to do but replace it. Just undo these terminals. Recycling an old power cable here. It's actually in really nice condition and has a moulded plug. And there, looks quite posh. Feed the cable through the gland. There we are. These wires need to be a fair bit shorter. Just going to chop them off there. Just bare the ends off. I'm going to tin the tips of these wires, stop them fraying. It's time to test it. I want both of these channels on and some test leads in here. That's for the one channel. And this is for channel 2. I'm going to clip these on the back of the speaker terminals because they're just easy to get at. Make sure you don't get the ground on the wrong terminal. That's how you blow amps up. And put a new cable in the test socket. And this will power the amp with some light bulbs in series. Bit of inrush current there, but it seems to have settled nicely. No silliness on the speaker outputs. That's a good thing. Just want to monitor the bias of these boards whilst it's in situ. Onto the CT terminal. And PE. So channel A and channel B. We'll just leave that to warm up for a while, see if we get the 10 millivolts that we're expecting. But in the meantime, I've got a bit of news for you. I moved to a new workshop. So this is the last video you'll see in here. They both drifted above the 10 millivolts we're looking for by about the same amount really. Just going to tune them down a bit. I think that'll do. Take these test leads off now. Let's give it an input signal. Those look nice healthy outputs. Let's compare the amplitudes. Yeah, they're pretty tightly matched, they are. just going to connect one channel into the analyzer, see if it's getting the output it should. Although I can't remember, they make it display the power. There we go, 19.0 for power into 8 ohms. 19.0. Now you're going to power it on. I'm going to back these off before I increase the input signal, see if I can get the max out of this thing. And I think we need 2 volts. I'm going to back these off as well, because 200 watts into 8 ohms needs 40 volts RMS. Let's switch channels on here, put the analyzer on the B channel. And now both channels together. So channel A all the way to 200 watts. Now channel B. There we go, the amp is running flat out. Can't do that all the time, mind you. Remember, 12.5 watts. Well, it's passed the full load test with flying colours, so I'm going to put the lid on. Although, to look at these scratches on, it actually looks better upside down. Looking nice and tidy now. Just one problem, these transistors are still exposed, and that's a bit of a safety hazard. I measure from there to there, nearly 160 volts. I can't have this leave the workshop in that state, so I need to make new covers. I have found one of these for sale on eBay, about 15 quid. It's a bit steep for one cover, and he's only got the one. That's no good to me, but it's given me some ideas for the design. But I don't think I'm going to put slots in it, because that's going to be quite difficult to do. I might go with a round hole design. And here's my version of the covers. I'm going to use round holes. I'm just going to drill in there. A lot easier than putting slots in. And I've also allowed for a bit of stretch when you do the bends. You have to watch for that. These things grow when you bend them. But this will at least make use of this scrap steel I've had lying around for many years. With the black paint on, these look quite professional, but they are missing something. The originals had a warning message on there telling you not to remove them. I think it would be a very good idea if I put the same warning on these replacements. And this will be making them on my favourite label printing machine, the CPM 100H. It's very much a professional printer, and I don't use it for conventional uses, but I have to say their technical support is brilliant. It's actually a thermal ribbon print, and it has the limitation that it only prints solid colours. And some of the ribbons are a little bit translucent, which can be a problem when you're printing on black. But I found a way of getting it to print layers, which gives me quite a large palette. To make this colour grid, I printed all the same colour squares going all the way across there first. Then on top of that, I printed them again over here. You can see all these different shades that are available. And all the lettering on here is a slightly yellowy cream colour, and the closest I can do here, I think, is this. So I need to print the gold on top of white. That will do it. So I'll load the white ribbon first. Now I've just got to design the label. You can make most labels in the printer's own software, but I personally prefer using Visio for the design, mainly because I use it for the other designs I use where all the measurements are scaled up, so it makes sense just to draw the labels in the same package. So just grab hold of the text off here, copy it, just paste it in the printer software. In fact, I want 4 of them for the 4 covers. It'll also cut the labels out if you tell it what shape they are. And pretty much all my labels are rectangles, so there we go. So just drag it over here. Just neaten it up a bit. And then you just set it to be a cut shape. It's showing this little dagger icon. But it's also going to print this rectangle, so we need to get rid of that. It's easy done by just going to the line attributes and say none. The next step is to set a colour of this Visio object. Although it looks black, it could be anything. Because I'm using solid colour ribbons, I'm going to choose those, and I'll set this to be white. Now if I tell that to print now, I just get 4 labels with white writing on, but I want to put gold on top of the white, and this printer software doesn't actually want to do that. So what I need to do is put another object in here that's going to trip the printer up. Something like a simple line, and just plonk it right at the top. Doesn't matter where it is really, just not where the labels are. And the trick here is to give it a different colour. I'm going to go with this, because I don't use that one at all. Now I can just simply tell it to print. It's giving me the option here if I want to print several hundred or whatever. Just the one will do, thank you. Now it's asking me to put the other colour ribbon in, but we're going to say no thanks. Stop there. Now I'm going to select these text objects and change their colour. Custom colour 2, or whatever colour you want them. And I also don't need this here anymore. Now we can open this up. Let's pull the white cartridge out and put this gold one back in. Then we just click print again. Well, that hasn't taken too long at all, and the best bit is it's put them all out for me. Well, that's a full set there. I'm quite pleased with those. Let's see how well they fit. This old Yamaha's still a bit dinged and dented around the edges, but it's better looking than it was. It now works in stereo and not as dangerous. Catch you next time.